Today we're going to talk about Soh-Cah-Toa, and Andrew wanted me to start off different. Instead of saying hi all, I'm going to say hi Andrew. How's it going, Andrew? Andrew, do you remember last year you learned all about Soh-Cah-Toa? Well, we're going to apply Soh-Cah-Toa to all of our 6 trig functions now, and we're going to learn what Soh-Cah-Toa means for all of them. So let's review. Soh-Cah-Toa. So is opposite for sine. So means sine is opposite over hypotenuse. So we already know that sine is y over r, so let's write down opposite over hypotenuse. I'm just going to write hype. Okay, so it's the opposite over hypotenuse. The ca means cosine is adjacent over hypotenuse. So let's go ahead and write down adjacent over hypotenuse. And then the toa means tangent over, tangent is opposite over adjacent. So let's go ahead and write that down. And then how would we figure out the same thing using opposite, hypotenuse, and adjacent for our reciprocal functions? Well, for cosecant, cosecant again is the reciprocal of sine. So we just flip the opposite over hypotenuse is now going to be hypotenuse over opposite. For secant, instead of adjacent over hypotenuse, it's going to be hypotenuse over adjacent. And then for cotangent, instead of opposite over adjacent, it's going to be adjacent over opposite. So let's go ahead and use that information to solve the 2 problems that I have written to the right-hand side here. So in the first problem, we're given a right triangle with sides 7, 24, and 25, and it's asking find the sine of theta and the cosine of theta. So let's go ahead and use our Soh-Cah-Toa rules to find the sine of theta. The sine of theta is always the opposite over the hypotenuse, so it's 7 over 25. So we have one answer. Cotangent of theta, let's go down here to cotangent. It's adjacent over opposite. So our adjacent side is always one of the legs that makes up your angle. So our adjacent side is 24, and our opposite side again is 7. So we've answered that question. So let's go ahead and take a look at the next type of question you might get on your homework. One of the things that I didn't put in here in the instructions is that B and C are B is a leg of a right triangle and C is the hypotenuse. So let's draw in our right triangle, and we're going to say B is one of the legs, and I'm just going to put B here, and C is always the hypotenuse. A and B are legs, C is the hypotenuse. And the question is, if these are legs and the hypotenuse of a right triangle, find the tangent of theta, and theta will always be this angle right here. So how would we find tangent? Well, we know tangent is opposite over adjacent, but we don't know what the adjacent side is. So let's go ahead and solve our triangle for the adjacent side, and I'm going to call this side A. So we know a squared plus b squared equals c squared from Pythagorean's theorem. We don't know a squared, but b squared is 64, and c squared is 121. So when we subtract those, what do we get? 36 and 21 is 57. And if we take the square root, a is going to be the square root of 57. Let's see, 5 and 7 is 12, so it is divisible by 3. So we have 3 times 19. Okay, it's not going to reduce any further. So I know that a is the square root of 57, and that tangent is opposite over adjacent. So my tangent here is going to be 8 over the square root of 57, and I have to rationalize that. So my final answer is going to be, let me erase this really quick. My final answer is going to be 8 radical 57 over 57. And that's how you use Soh-Cah-Toa for not just sine, cosine, and tangent, but cosecant, secant, and cotangent.